Okay, let us see first law of thermodynamics. As I said before, the first law of thermodynamics said that, or indicates, the conservation of energy, and it said that the change in internal energy of a system is equal to the heat added or lost to the system plus what? The work done on or by the system. This indicates that if work is done on the system, that means energy is added to the system. If the work is done by the system, energy is lost by the system. Therefore, it makes negative and positive depending on the situation. And heat lost and also added to the system makes negative and positive. That indicate that the lost and gain of heat energy. Therefore, if the question says, or if it says work is done on the system, it's indicate that what? Heat or energy is added to the system. That makes the work done positive. If it says work is done by the system, it becomes what? Negative, because if the work is done by the system loses what? Energy. Let us see one example. For example, if the system has 60 joule of heat added to it, that means since it says added, it's what? Positive, and resulting in 20 joule of work being done by the system. Since it says what? By indicate that work is done by the system, that means the system loses energy in terms of work. That makes negative the work done. Therefore, heat energy minus work done is the equation. Then heat energy is 60 joule minus 20. It indicates, or it gives us 40 joule. But if this equation is changed to, if 60 joule of heat is added to the system and work is 20 joule is work is done on the system, since it says added, the heat energy is positive and the work is done on the system, this one is also positive. The internal energy of the system will become the sum of the two. That makes 60 plus 20, it's what? 80 joule. And if heat is added to the system and no work is done, then the heat lost by one element in the system equal to what? Heat gained by another element. For example, if we heat up some metal and we drop into a beaker of water, the heat lost by the metal is equivalent to the heat gained by what? The water. Therefore, the heat energy gained by the water is equivalent to the heat lost by the metal. And we can study the PV diagram, the thermal process that utilize the ideal gas. We can study change in pressure, volume, and temperature of a gas by plotting what? Graph that is pressure versus volume of a particular process. We call this PV diagram, as we said before. For example, let us say that the gas starts out at a pressure of 4 atmosphere at this point, and the volume of the gas is 2 liter at this point A, and then as shown in point A in PV diagram below. And if the process of the gas remains constant by the volume of 4 liter, that means pressure constant, and if it expands and reached to B, the volume is increased by what? By 2. It becomes 4 liter. That means it becomes A to B. The line or the arrow A to B indicates the expansion of the gas from 2 to 4 liter of volume. And since the pressure is constant from A to B, we can say the process is what? Isobaric. Therefore, isobaric process is a process of thermal process at constant pressure. Then, if we decrease the pressure to 2 atmosphere, but keeping what? The volume constant, that means B to C. At this point, the pressure is decreasing, but the volume is what? Constant. And we can say this constant volume process is what? Isochoric or isovolumetric process. Most of the time we call isochoric process. And if we want the gas to return to its original state with change in temperature, without change in temperature, that means making the temperature constant, that indicate that C2A, the diagram C2A, Since the temperature is constant, the process is what? The process is, without changing temperature, trace the point C to A along an isothermal process. Since it says isothermal process is a process at constant temperature. Note that the isothermal on PV diagram is not straight line, it's a curve. The work done during the process ABCA, that means over the closed loop, is the area. Which area? This area. This area enclosed is the work done by this process. Therefore, we can take or we can calculate the area enclosed to get the work extracted. Any process which is done without transfer of heat is called adiabatic process. That means without transfer heat. That means if changing Q or Q is 0, that means if the internal energy of a system is only determined by the work done by or on the system, we can say the process is what? Adiabatic process. And we can summarize this by some table. When we say isobaric indicate that constant pressure, and the graph looks like a straight line, horizontal straight line, that is PV diagram. On PV diagram, the pressure is constant, but the volume is increasing, that means expansion or compression. And in isobaric, the volume is what? Constant, therefore vertical horizontal line. And in isothermal, the temperature is what? Constant. And in adiabatic, no heat is added or taken away from the system. That means the internal energy is only determined by the work done on or by the system. Let us see one example. We have some diagram for the separator process AB, AC, AD, AE are represented on PV diagram above for an ideal gas. Determine the work done by the gas during AB. We can take the area under the AB graph, this area, and the area is what? Rectangular. Since it is rectangular, P times change in V. P is, the pressure is how much? 8 times 10 to the power of what? Positive 5, because this pressure is expressed in terms of what? 10 to the power of 5. 8 times 10 to the power of 5 is for A to B, the pressure. Change in volume is, initially it is at 2 meter cube, and it's increased to what? 4. Therefore, this one is the final and this one is the initial. Therefore, 4 meter cube minus 2 meter cube. And our final answer is 1.6 times 10 to the power of 5 joule. Question number 2, B. Determine the work done on the gas during A to E. During A to E, the change in volume is what? 0. That means the volume is what? Constant. If the volume is constant, the internal energy of the system is 0. Therefore, in B, there is no work during A to E, since there is no change in what? Volume. Therefore, 0 is equal to change in Q plus what? Change in work done. This one is for constant volume for isochoric process. C is the work done on the gas during any process on the diagram. If so, identify each one and explain how you know work is done. We have work in the 3 diagrams, A to B, AC, and AD, because there is increase in volume, that means change in volume. But A to E, we don't have any work, because work done by any gas is equivalent to what? P times change in V. If there is no change in volume, there is no work. Therefore, from A to B, AC, and AD, since there is change in volume, there is a process or there is a work done. But in A to E, we don't have any work. In D, identify the process which could be isothermal and adiabatic. A to C and A to D. The process A to D is isothermal. That means this one. You can differentiate by the curve. If the curve is somehow exponential decay, high exponential decay, it's isothermal. If it is the curve is moving up or smaller than the second, the smaller curve is adiabatic. Therefore, A to D is isothermal and A to C is what? Adiabatic. In E, we are asked to calculate the heat loss during the process A to E. The heat loss during the process A to E is equivalent to Q is equivalent to, since the volume is constant, change in pressure times what? Volume. Therefore, change in pressure is the pressure decreases from 8 to 4. Therefore, 8 minus 4 times 10 to the power of 5. That means 4 times 10 to the power of 5 minus 8 times 10 to the power of 5 times what? The pressure, the volume is 2 meter cube, and finally we can get negative 10 times 10 to the power of 5 joule. This negative sign indicates the lost energy, the heat lost. Let us see second law of thermodynamics. Entropy, as we said, or as we see before, entropy is the measure of what? Disorder or randomness of a system. The greater the disorder of a system, the greater the entropy. If the system is highly ordered, like particle in a solid, we say that the entropy is low. That means it has low disorder. At any given temperature, and a solid will have lower entropy than what? Gas, because the individual molecule in a gaseous state are more random, while individual molecules in solid contained is in place. Entropy is important because it determines what? Whether the process occurs spontaneously or not. Therefore, the second law of thermodynamics states that all spontaneous process spreading in isolated system leads to what? Increase in entropy. Therefore, as I said before, second law of thermodynamics is expressed or explained in so many ways. Among these, the second law of thermodynamics states that all spontaneous process proceeding in isolated system leads to an increase in entropy. Therefore, in any system in the universe, the entropy of that system is always what? Increasing. The entropy does not decrease. The other thing is heat engine. A heat engine is any device that uses what? Heat to perform work. There are essential features of heat engine. Heat is supplied to the engine. Okay. Heat engine is any device that uses heat to perform work. There are three essential features of heat engine. The first one is heat supplied to engine at high temperature from a hot reservoir. 1. 2. Part of the input heat is used to perform what? Work, and the remain of the input heat did not do work. That work is what? Exhausted, or it's moved to cold reservoir, which is at lower temperature than the hot reservoir. Therefore, we have an input. This input is at high temperature of heat reservoir. Some of these inputs makes mechanical work, and the other is what? Exhaust heat at lower temperature of reservoir. In the diagram above, heat is used to do in lifting the block which is sitting on the piston of the gas fixed with cylinder. At heat left over the after work is done exhausted into the lower temperature of reservoir. This diagram is used for example 2 below. For the lower example, the percent efficiency of the heat engine is equal to the ratio of the work done to the amount of heat added, as we see before in the basic pointers. Therefore, efficiency in percent is equal to work divided by heat reservoir, the heat energy or the heat added to the system, multiplied by 100%. Therefore, Therefore, we have three figures here. In this example. The figure above, heat is added to the cylinder in figure 1, where the gas occupies half the total volume of the cylinder, rising it to the top of the cylinder in figure 2. And heat is then removed and block is lowered so that the gas occupies what? 1/4 of the total volume of the cylinder. The total volume of the cylinder is 2 times 10 to the power of -3 meter cube, and the area of the piston is given, and the mass of the block is also given. If in A, we are asked to determine if the block is at rest in figure 1, determine the pressure of the gas in the cylinder. To do this, as you know, pressure is equal to force over area. But here, this cylinder is open. Since it's open, there is another pressure which is acted upon, that is atmospheric pressure, P atmosphere. Therefore, the atmospheric pressure at ground level is 1 atmosphere. Therefore, force over area plus what? 1 atmosphere is used. And force over area, since there is the weight of the object, that is mass times gravity, which is 2 times 10, it becomes what? 20 divided by 0.05 and plus 1 times 10 to the power of 5. Finally, we can get 1.004 times 10 to the power of 5 Pascal. This one is the pressure which is exerted on the first figure. B, it is determined that the efficiency of this heat engine between 1 and 2 is 60%. How much heat was added to the cylinder? If the efficiency is given in figure 1 to cause the piston to raise level 2, or in figure 2. Therefore, first we must determine what? The work done by increase in volume. Therefore, in piston 2, in the second diagram, from half it moves what? Total. That means from half to total increased. Therefore, work is equal to P times change in V. The pressure is known. We calculated here. Therefore, 1.004 times 10 to the power of 5 Pascal, and half of the total volume. Change in V is half of, because from half to total, therefore half of 2 times 10 to the power of -3 meter cube. ምክንያቱም መጀመሪያ የነበረበት እዚህ ጋር ግማሽ ነበረ፣ ከግማሽ ሙሉ በሙሉ ነው ሙቭ ያደረገው። ስለዚህ ከግማሽ ወደ ሙሉ ስለሆነ የጨመረው ወይንም ሙቭ ያደረገው ቼንጁ ግማሽ ቮሊዩም ነው ማለት ነው። ስለዚህ ግማሽ ቮሊዩም ስለሆነ የቶታል ቮሊዩሙን ሃፍ እንወስዳለን ቼንጅ ላይ። therefore if you make, or finally you can get this amount of work from the equation. Percentage of efficiency is equal to work over what? Q hot times what? 100%. If you make crisscross, finally you get Q input or Q hot is equal to work over efficiency. Efficiency is how much? 60%. That means 60 divided to 100, 0.6. Therefore, this work divided by 0.6, finally you can get this amount. The lost heat energy is calculated by using QH. That means QH minus what? Work gives us Q lost, or heat or energy, or Q lost. Therefore, how much energy is lost? 66.9 joule of energy is lost. In C, in the process between figure 1 and 3, isothermal, isobaric, or isocalc, explain it. As we see, there is change in pressure, no change in volume, but the pressure is what? Constant. Therefore, the process between figure 1 and figure 2 is what? Isobaric, because the pressure of the block of the atmosphere applied to the piston and the gas does not what? Change during this, but the volume is changing. Since the pressure is constant, it's what? Isobaric. In D, we are asked to determine if the temperature of the gas in figure 1 is 40 degrees Celsius. What is the temperature of the gas? Therefore, to do this, we can use the temperature is known. We can change this temperature to Kelvin. Then V1 over T1 is equal to what? V2 over T2. And by making crisscross, T2 is equal to what? T1 over V1 times V2. Therefore, we can substitute these values. After we substitute, you can get in Kelvin 660 Kelvin of temperature. In E, between figures 2 and 3, is the system acting as a heat engine or refrigerator? Explain. And determine the temperature of the gas in figure C. Therefore, in E, to answer the first, the system acting as a refrigerator because removing heat from the cylinder. Refrigerator removes heat energy from a substance which is put in the refrigerator. Therefore, this system, in the third system, initially at this point the heat energy is larger, and at this point heat energy is what? Decreased. The volume is decreased. Therefore, it removes what? Heat energy. Since it removes heat energy, the process or the material is acting as a refrigerator, removing heat energy and reduces in volume. Therefore, because of this, it's acting as refrigerator. Since the pressure remains constant between 2 and 3, to calculate the temperature, we calculated temperature of the second. Therefore, by taking the ratio, finally you can get 154 Kelvin of temperature. And the last point is Carnot's principle and Carnot's engine. Carnot is French engineer, suggested that heat engine has maximum efficiency when the process within the engine are what? Reversible. That is, both the systems and its environment can be returned to exactly the state they were in before the process occurred. And in other words, there can be what? No dissipative force like friction and air resistance, and involving in Carnot's cycle of an engine for it to operate at maximum efficiency. All spontaneous processes such as heat flow from hot reservoir to cold reservoir are not reversible, since work would have to be done to force the heat back to the hot reservoir from the cooler reservoir, just like refrigerator. In a refrigerator, we have what? This one is a refrigerator. At the bottom, we have a cylinder or a material which have a gas. And this material, when you make or when you connect with a power source, this cylinder pumps the gas to move up, and at this point we have a filter, and this filter makes this gas to cool, and after it cooled, it entered to the central part of the refrigerator. And in the refrigerator, the materials are at higher temperature than the gas. Therefore, heat energy is extracted from the materials by the gas, and the gas makes what? Hot, and backs to the cylinder. And the cylinder again pumps this gas, and the cycle is being processed or increased. And always, as you know, the back of the refrigerator is hot because this cylinder makes the gas inside, the heat inside the refrigerator is extracted and exhausted in the outer part of, or in the back part of the refrigerator. Therefore, this process is by Carnot engine. Therefore, if there is additional work, here the work is done by what? By the cylinder or by the gas. Here, additional work is done by the cylinder when you connect with electrical power. Therefore, since there is an external work, heat energy can flow from lower temperature to higher temperature. This is Carnot's principle. This is all about today. Until next time, have a nice time.